Imagine like paying $30,000 for a home upgrade, right? And knowing that over 60% of that money is just going directly to a crew that's literally destroying your backyard with heavy excavation equipment.
Yeah, it sounds completely counterintuitive when you put it like that.
I mean, you aren't getting this sleek, fancy appliance dropped off in a cardboard box. You're basically funding a localized mining operation. But despite the mess, it might just be the single greatest financial and energy efficiency decision you will ever make for your property.
It really is, the ultimate test of looking past the surface. We're so conditioned to buy consumer tech that plugs into a wall. But geothermal energy forces a homeowner to literally integrate their house into the earth. It's a profound shift in how we think about heating and cooling, which, well, it creates a huge psychological barrier for most buyers.
Definitely. And welcome to the deep dive. For you, the listener tuning in to figure out how things actually work underneath all the marketing buzz and, literally underneath the soil, we have a really fantastic breakdown today.
We do. We're exploring the gritty reality, the localized economics, and the largely invisible challenges of residential geothermal energy.
Right, and our sources for this are great. We are pulling directly from the field notes of Dave Hartzell. He's a 45-year master HVAC technician operating out of Oklahoma. He recently put together this broadcast script analyzing an extensive ACHR News deep dive series from mid-2025.
The value of Hartzell's perspective is that he just completely bypasses the glossy manufacturer brochures. We're looking at this through the lens of the technicians who have to physically design the systems, the drillers breaking through bedrock, and of course the homeowners financing all that dirt work.
Our mission today is to uncover the geothermal paradox. Basically, why a technology that supposedly checks every single box for sustainability and efficiency is sitting in so few homes today.
Exactly. It's a fascinating disconnect.
Okay, let's unpack this. Because the gap between public awareness and actual consumer adoption is just stark. And the ACHR News survey didn't just ask a handful of random people. They pulled data from over 500 industry players.
Right. It's a very solid sample size.
Yeah, and they split it incredibly evenly. We're talking 129 residential contractors, 128 commercial contractors, 124 homeowners, and 122 facility managers.
So we have the people digging the holes, the people paying the invoices, and the people managing the buildings long term.
Exactly. And looking at the homeowner data specifically, 41% said they had some working knowledge of geothermal systems, but a microscopic 1% actually had the technology installed in their homes.
Which is wild. You see those numbers and you'd usually assume, well, the market must just hate it.
Right, like maybe the equipment is fundamentally flawed. But usually when a technology is this good, early adopters jump on it and drive the price down, like with flat-screen TVs or electric cars. So what does this all mean?
What's fascinating here is that the technology is not the problem at all. The survey actually reveals the doors wide open. 32% of homeowners said they would be interested in installing it, 36% said no, and 32% weren't sure.
Wow, so almost 2/3 of the market is either open to buying or just needs someone to, explain the value proposition to them.
Right. The barriers are really education, upfront cost, and geographic doubt. That gap highlights a massive industry-wide failure in education. Contractors are just struggling to communicate how the underlying mechanics operate.
And there's this lingering anxiety over geographic compatibility, right? Like people assume you need a hot spring or a literal volcano in your backyard to make geothermal work.
Exactly. They're confusing residential ground source heat pumps with utility-scale geothermal power plants. They are completely different things.
Yeah, let's clear that up right now. Hartzell's notes break down the physics so brilliantly. We are not tapping into magma.
No, not at all.
If you go about 12 feet down into the earth, even in a state like Oklahoma that gets hit with, blistering summer heat waves and brutal winter ice storms, the ground temperature basically just stabilizes. It sits at a highly predictable, constant temperature, usually right around 55 to 60 degrees year-round.
And that layer of soil basically acts as a permanent infinite thermal battery. There is no combustion. You aren't paying a utility company to ignite natural gas to create heat. You're simply moving existing heat from one place to another.
Right. So in July, when your living room is 90 degrees, the system absorbs that thermal energy and pumps it down into the cooler 58-degree earth. It's effectively dumping the heat into the dirt.
Yeah, dumping heat into cooler ground makes logical sense to most people.
Yeah.
But winter is where people get stuck.
Oh, totally. Because if it's 10 degrees outside and the ground is only 58 degrees, 58 degrees isn't warm enough to heat a house to a comfortable 72. So how does 58-degree dirt actually warm up a living room without burning any fuel?
This is where the magic of the refrigeration cycle comes in. The system circulates a fluid through those underground pipes. That fluid absorbs the 58-degree ambient heat from the dirt, brings that relatively low-grade heat inside your mechanical room, and transfers it to a specialized refrigerant.
Okay, so it pulls the moderate heat inside.
Right, and here's the crucial step. A compressor then squeezes that refrigerant gas. Basic physics dictates when you compress a gas, its temperature skyrockets. Think of how, like a bicycle pump gets physically hot to the touch when you vigorously pump air into a tire.
Oh, yeah, that makes perfect sense.
So the compressor takes that 58-degree baseline and forces it up to over 100 degrees, which is then just blown through your ductwork.
So you're basically taking free, moderate heat from the mud, concentrating it through pressure, and using that to heat your house. You only pay for the electricity to run the compressor and the fan, right?
Precisely.
Yeah.
Which requires just a fraction of the energy needed to generate heat from scratch. The technology is incredibly elegant and mechanically sound. The hurdle is not the appliance itself.
It's what it takes to connect that appliance to the dirt battery.
Exactly.
And looking at the breakdown here, I was genuinely surprised to see where the money actually goes. The actual heat pump unit, like the metal box sitting inside your house, only accounts for 20 to 40% of the total budget. On average, just 30% of the project cost goes to materials.
The remaining 70% is entirely swallowed by labor, trenching, drilling, and loop installation.
Wow.
Yeah, once the job is finished, the vast majority of your investment is completely invisible, just buried under your lawn.
Here's where it gets really interesting for me. Buying a geothermal system isn't like buying a refrigerator. It's more like paying for a major landscaping and mining excavation project where you just happen to get an appliance at the end.
That's a perfect way to look at it.
And the ACHR sources outline several ways contractors actually get that pipe into the ground, depending on how much land you have, right? Like the most common in suburbs is a vertical bore, where they bring in a massive rig and drill straight down hundreds of feet deep.
Right, vertical bores are necessary when you have a small footprint, but they're super expensive because of the heavy machinery required. Now, if you own a few acres, a contractor might opt for a horizontal trench, bringing in a backhoe to dig a long, shallow network of trenches about 6 feet deep.
Which requires less specialized drilling equipment, but tears up a much larger area of land.
Exactly. There are also horizontal pits, directional drilling techniques that bore underneath existing landscaping, and pond loops. If you happen to own a property with a deep lake or pond, they can submerge coils of pipe directly into the water, which is incredibly efficient and bypasses the heavy earth moving entirely.
I imagine the type of soil you live on dictates a huge portion of that cost estimate, too.
Oh, geography and geology are the absolute dictators of cost. Hartzell provides a great localized contrast from central Oklahoma. If a contractor is quoting a job in Kingfisher County, they're dealing with dense hard pan and thick red clay.
Which means tougher drill bits, moving slower, more wear and tear on the machinery.
Right. But if you move to a different county with soft, sandy soil, the drilling goes much faster. However, the thermal properties of the soil change entirely.
Wait, let's explore that. Does the type of dirt actually change how well the heat pump works?
Dramatically. It all comes down to thermal conductivity. Wet clay is fantastic at transferring heat. Dry, sandy soil is actually a decent insulator, meaning it, resists heat transfer.
Oh, wow.
Yeah, if you bury a pipe in dry sand, you might need twice as much pipe to extract the same amount of heat as you would in wet clay. This is why Hartzell strongly emphasizes the necessity of IGS-HPA accreditation.
That's the International Ground Source Heat Pump Association, right?
Yes.
So it isn't just about knowing how to drive a tractor. The contractor basically has to be part geologist.
Exactly the point. Proper loop design requires mapping the thermal conductivity of the specific dirt in your yard. If an unaccredited contractor installs a loop that is too small for your soil type, the system will slowly extract all the heat from the ground around the pipe until it literally freezes the dirt solid in the middle of winter.
Oh my gosh, that's wild.
The system will just fail. You cannot just guess at the math. It requires highly specialized engineering.
Which brings us to the biggest bottleneck revealed in these surveys. If 60% of the cost is digging the hole, who is doing the digging? Over half of the HVAC contractors who outsource their earthwork reported that finding a qualified, willing driller is their single biggest business challenge.
We have to step into the realm of behavioral economics here. Put yourself in the shoes of a local excavation company. You own a $500,000 drilling rig. You can choose to drill water wells, or you can choose to drill geothermal loops.
Okay.
Drillers overwhelmingly prefer water wells.
Why? I mean, a hole is a hole, isn't it? As long as the check clears, why would they care what kind of pipe goes down it?
Because the risk profile and the business model are entirely different. Digging a water well is relatively straightforward. Every new rural build, every farm, agricultural properties, they all need water. It's consistent, reliable work, and more importantly, it's lower liability for the driller. Geothermal, on the other hand, is considered high-effort, low-repeat business.
High effort because of that complex thermal engineering we just talked about. The trenches have to be perfect, the header pipes have to be fused precisely, and, the property damage is extensive.
Yes. And consider the low-repeat aspect. If a driller installs a water well, there's a pump that eventually breaks, meaning they might get future maintenance work. If a driller perfectly installs a geothermal loop, those pipes sit safely underground for 50 years. The customer will never call that driller again.
Wow, so no repeat business?
None. Plus, if a fusion joint on a geothermal pipe leaks 10 years later under a client's pristine driveway, the liability and the cost to excavate and fix it is an absolute nightmare.
Wait, so this massive green energy transition is essentially stuck in traffic because the guys with the drills look at the risk-to-reward ratio and decide they would rather just dig for water.
Precisely. And that supply shortage directly inflates pricing and stretches scheduling out for months. An HVAC contractor who wants to sell a geothermal system is entirely at the mercy of the driller's calendar.
Which explains why Hartzell notes that local veterans in the industry spend years, sometimes decades, building deep personal relationships with specific excavators just to ensure their clients don't languish on endless waiting lists. You aren't just paying for the drill, you're paying for the contractor's exclusive Rolodex.
Exactly.
Taking all of that into account, the custom geology, the heavy equipment, the shortage of drillers, we really have to look at the hard numbers. Is the return on investment actually worth the monumental hassle? Let's drop the sticker price right now for the listener.
Utilizing Hartzell's Central Oklahoma estimates, a typical 1,800 to 2,500 square foot home requires a significant upfront investment. You're looking at roughly $15,000 to $30,000 for a complete installation.
That is easily 2 to 3 times the cost of calling a guy to swap out a conventional air source heat pump. That kind of sticker shock will make most homeowners instantly hang up the phone.
It is a steep mountain to climb. But we have to factor in the operational math. A conventional system guarantees a high utility bill forever. A geothermal system immediately drops your monthly heating and cooling costs by 50 to 70%.
We also need to define how these systems are sized, because the sources mention rebates based on tons. And to a homeowner, that jargon is totally opaque. A ton of capacity doesn't mean the physical weight of the machine in your basement.
No, it's an old HVAC measurement. 1 ton of capacity equals 12,000 BTUs of heat extraction per hour. An average-size home typically requires a 3-ton to 4-ton system, depending on its insulation and layout.
That becomes critically important when we talk about longevity. The indoor unit, the actual compressor shielded away inside your utility closet, lasts 20 to 25 years because it never faces the elements.
Right, there is no noisy metal box outside getting pelted by hail, rusting in the rain, or suffocating under a snowdrift.
And that expensive underground loop, that infrastructure is rated to last over 50 years. You pay for the dirt work once, and you might never need to install another loop in your lifetime or even your children's lifetime.
It's an incredible long-term play.
But financing that initial $30,000 has just undergone a massive shakeup. This is a critical reality check for anyone listening in 2026. For years, the industry relied heavily on the federal geothermal tax credit, known as Section 25D, to offset that brutal installation cost.
Yes, and as of December 31st, 2025, that federal credit officially expired. It is completely gone for 2026 installations.
Hartzell points out something incredibly frustrating here. There are still contractors operating in the field who are casually dangling that expired 2025 federal credit to close sales with uninformed buyers.
Which is why relying purely on a salesperson for your financial planning is dangerous. As a homeowner, you have to be vigilant. Verifying tax codes and local incentives independently is absolutely essential to protect yourself from outdated or downright deceptive sales pitches. You must do your own homework.
But there is a silver lining. While the federal government stepped back, local utility companies have aggressively stepped forward. Local utilities are terrified of peak demand destroying their grids during extreme weather. Since geothermal systems use drastically less electricity, the utilities are heavily subsidizing the installations to keep you off the grid during rush hour.
Right, and Hartzell provides specific, verified examples from his territory in Oklahoma to show how radically these local rebates alter the math.
The numbers are substantial. Seek Energy is offering a rebate of $2,000 per ton of geothermal capacity, capped at $24,000. For a standard home needing a 3-ton system, that is a $6,000 check handed right back to you.
That's huge.
Yeah, and OG&E is offering $1,000 per ton. Smaller regional players are in the mix too. Cimarron Electric offers $600, and KPWA, a city utility in Kingfisher, has confirmed active rebates.
When you take a $30,000 quote, instantly knock $6,000 off the top with a utility rebate, and finance the remaining $24,000 at a reasonable rate, the economics suddenly makes sense.
It really changes the conversation.
In many cases, the 70% savings on your monthly electric bill completely covers your new loan payment. You are simply taking the money you used to burn on utility bills and redirecting it into an equipment loan. Once the loan is paid off, you own a hyper-efficient system with a 50-year loop.
It's a cash flow swap, but you have to pick up the phone and call your specific utility provider. Your neighbor 3 streets over might be on a different grid with completely different incentives.
That is the ultimate takeaway. Geothermal isn't a neat, standardized product. Every single installation is a highly customized intersection of your local soil, your local utility provider, and your local driller schedule.
Which brings us full circle. Geothermal isn't some magical futuristic technology waiting to be invented. It's a highly reliable, earth-driven system that has been proven for decades. It's just currently choked by an education gap where consumers don't understand the physics of moving heat, and a major logistical bottleneck where the excavation industry is hesitant to take on the liability of custom earthwork.
For you, the listener, understanding the real reasons behind that steep price tag changes the dynamic completely. Knowing that you are paying for specialized geological expertise, heavy machinery, and the time of a highly sought-after driller makes you an empowered homeowner.
Right.
When a contractor hands you a quote for $30,000, you are no longer suffering from sticker shock over an appliance. You know exactly what kind of infrastructure project you are commissioning.
You are tapping into the Earth's thermal battery. Which leaves me with a final thought for you to mull over. If the biggest hurdle to widespread residential geothermal adoption isn't the technology, but simply a lack of people willing to drill the holes, what happens to the housing market and our energy grid in the next decade?
It's a great question.
If a new generation of tradespeople suddenly decides that high-effort geothermal digging is the ultimate bottleneck to green energy, could it become the most lucrative career path of the 2030s? We constantly look to Silicon Valley for the next big tech boom, but maybe the future of home energy doesn't require writing code at all. Maybe the next tech boom could actually be an earth-moving boom.
Until next time, keep digging into the details.